Hello there and then welcome to a brand new video. This is Happy Beyond Numbers where we learn maths the easy way. In this lesson, we are looking at application of vectors in geometry, and specifically we are looking at how we apply vectors in parallelograms. So without much ado, let's quickly go into it. Now, before we begin, let's quickly look at what a parallelogram is. So something like this here, that is a tilted rectangle, is what we call a parallelogram. Now, what are some of its properties? So it has some fascinating properties that will help us in vectors. Some of which includes the parallel sides being what? Equal. Parallel sides here, we mean this side here and then this side here. They are equal, you see. And as you can see, if I take this to this, you see it fits perfectly. So parallel sides of a parallelogram are equal. Same applies to what you have over here, you see. They are what? Equal. Now, one other one is the diagonal lines that connect the vertices. They do what? They bisect each other. So what that means is this line here bisects this line also over here. Now, as we solve some questions, you would see how we apply these properties. So without much ado, let's quickly take some questions which we'll be applying these questions to answer. Okay, so for this question here, it says ABCD is a parallelogram such that A is given as -3 to C is 5, -3. And then we know vector AB being what? -4, 1. You have to find the coordinate of the point B and then D. Now, if you finish, you have to find vector BD. How do we go about this? First of all, you need to represent this so that you can have a visual of it. Okay, so let's use this I have done over here. And remember, it's not drawn to scale. It is not drawn to scale. So we have A, B, C, D. Now, A's coordinate was given to us in the question. Hence, we have written that clearly over there. That is -3, 1. B, we don't know. Hence, we use a variable. So x1, y1. And then C is 5, -3. And then we have our D here, which is x2, y2. Okay. Now, we have to find the coordinate of B and D. So to get this B here and then D here, B is very easy to get because we have been given AB to be what? -4, 1. Now we know that if we had A and then B, and we actually wanted AB, then AB would have been vector B, that is position vector B minus A. You see, but it has already been solved for us. Meanwhile, we know our A is what? -3, -1, as you can see here. And our B is x1, y1. So substituting AB, which you can see here to be -4, 1. So substituting, we have -4, 1 is equal to your B. So remember from here, we said our B was x1, y1. So x1, y1 minus the A. And our A was -3, 1. So simplifying, we have -4, 1 equals x1. And there's negative here. And then there's also negative here. So we have negative into bracket -3. Then for the y component, you have y1 minus your 1. You see, at this moment, we would want to take the x components and then solve them separately. And then the y component is also done separately. So for the x component, we have -4 being equated to what we have here. You see, so that we have -4 equals x1 minus -3. Evaluating further, we have -4 is equal to x1 then this becomes a positive 3. Hence, making x1 the subject, we have negative 4. Then our positive 3 moves to the other side to become a negative 3. So minus 3 equals x1, which then gives us a negative 7 equals x1. We have our x1 now. Hence, we go for our y component. So for our y component, we are going to evaluate this here, which is 1 is equal to your y1 minus 1. You see? And then trying to make your y1 the subject, you have 1. This negative 1 moves to the other side to become a positive 1. So 1 plus 1 equals y1. 1 plus 1 gives us a 2. So our y1 equals what? 2. Hence our b, which initially we said it was x1, y1, has now become what? Negative 7, 2. Hence you are done with b. Let's look at the next question. Now it goes on to say we should solve for d as well. You see, then how do we solve for d? It is still the properties we need to solve for the d. Now we're given ab. This here we're given ab. Using the properties of a parallelogram, ab would be equal to what? cd. You see, so we would say that since it is a parallelogram, vector a, b, you see, looking at the order a to b, then to be equal to d to c is equal to d to c. You see, and that would imply that dc is also equal to negative 4, 1. You see, now we know that to solve for dc, then it is actually c minus d. That is, dc is equal to position vector c minus d. Hence, we now do our substitution. So dc is negative 4, 1. Negative 4, 1. You see, and it's equal to our c, which we had as 5, negative 3. You see, that is from the question we were given. So 5, negative 3 minus the d, which we have said to be x2, y2, because we don't know it yet. So simplifying, we have our negative 4, 1 being equal to 4 minus x2. Sorry, 5 minus x2. So we have 5 minus x2. Then negative 3 minus y2. Negative 3 minus y2. So the same way, we'll now take x component and then solve them, and that of y, and then also solve as well. So starting from the x, for our x component, we have negative 4 being equal to 5 minus x2. Simplifying further, we have negative 4, then we have negative 5 equals negative x2. The reason being that this 5 moves to the other side to become a negative. You see, hence we have negative 4 minus negative 5, which is a negative 9 equals x2, negative x2. And since it is x we want and not negative x, we'll divide both sides by negative 1. So divided by negative 1. And our negatives cancel out, and it will imply that our x2 is equal to 9, or 9 equals x2. We now do the same for y. So we say for our y component, we are going to have what? An equation of these components, which means we have our 1 equals negative 3 minus negative y. So this is maintained here, whilst negative 3 moves to the other side, just as we did for the previous one. So you have 1, then if negative 3 moves, it becomes a positive 3. equals negative y2. 1 plus 3 gives us a 4. So 4 is equal to negative y2. And just as we did for the previous one, we divide by negative 1. We are doing that because we want to take out this negative. And with that, 4 divided by negative 1 gives us a negative 4. So it simply means our y2 is equal to what? Negative 4. And hence, D, which was x2, y2, is actually having the coordinate 9, negative 4. You see? So we've been able to solve for both points just by using the property of parallelogram, which says opposite sides are what? Equal. So with that cleared, we have to find the vector BD. BD. That is from B here to D down here. That is the vector we want to solve for. And I do believe you are familiar with doing that. So our vector BD is actually D minus B, right? And we have already solved for this already. So our D, which is 9, negative 4, minus the B, which is negative 7, 2. You just need to take your time and then evaluate. So we have 9 minus negative 7. That is 9 minus negative 7. Then negative 4 minus 2. And that will give us our B, D. Right? So evaluating further, we have 9 minus negative 7 becomes 9 plus 7. Then negative 4 minus 2 gives us a negative 6. You see? And 9 plus 7 gives us a 16. So 16 negative 6 is then vector BD. As simple as that. So just by understanding your basic vectors and then knowing your properties or the properties of a parallelogram or any plane figure, you can apply that to solve for sides, midpoints, and what have you. As usual, I'll leave you with some exercises you can try on your own. So here are just 5 questions that are similar to what we've solved. You can just solve any number of them and then test your understanding. If there's any issue of concern, you can always let me know at the comment section and I will address that for you. This is How Beyond Numbers, where we learn maths the easy way. If this is your first time, you can always choose to subscribe if you so do wish, so that anytime I release a lesson, you'll be notified as well. Stay blessed and see you in our next lesson. Bye for now.